So for him, these Goliaths, these early Goliaths, these early states were basically because you had a bunch of guys. He said it was basically gangs, like organized crime that started these states. But then what he shows is all the way through history. Then as time went on, you got these larger and larger Goliaths, Rome, Tang Dynasty, China, and now the modern one. But he says that almost always what brings them down are two things. One is climate. Because often you're sucking up all the resources that changes, either changes climate or changes the resources you have given the climate you have, or you have local climate changes. But even more importantly was inequality. Almost always it's inequality that brings the Goliath down. The inequality gets so large, the leaders, the kings, or whatever, are so, they're so over rich compared to the average person. And of course, they're extracting that wealth from the average person via taxes or whatever, that finally people are like, we're done. And they rebel. Or they leave. That's an interesting, either they leave, they just like, I'm done with the city, I'm going to go live in the hills. Right. Or they actually rebel. So that's a really interesting conclusion over all this time, that it's often inequality, which is clearly we have, it's insane the amount of inequality we have now. That this, the small group of people own 90%, the upper 0.1% owns whatever, 50% of the wealth in a nation or more. So I thought that was really interesting, that often you look at history and it's often inequality, which will sort of tap out how much, whether people are willing to put up with being governed,
Right.
Yeah.
Yeah, it makes you wonder where we're going to end up here in this civilization.
Yeah, because clearly, we see this. And that's actually the point was going back to the cell phone and AI and everything, was just that these technologies are amazing, but they have really only very few people have benefited financially from, it's a small fraction of the world that has really financially benefited from them, which is, especially when you get to things like robots, who owns the robots, right? If the robots are putting everybody out of work, the only people who are really, getting rich are the people who own the robots.
Well, Steven's a big advocate for robot police. He thinks robot police are going to solve all of our problems.
Or have robots being the policeman?
Yeah, he thinks robots should have full autonomy to kill people and make the decisions.
Oh man, that seems like, I think I've seen a lot of those science fiction movies.
Well, science fiction is meant for drama. Reality, if you give it rules, a robot police isn't going to get mad and shoot somebody.
Well, that's true. Right. There would be,
But my question is, who's in control of the robot police?
Right, exactly. And who, and what, and what biases, because, somebody programmed the robot police.
Someone's going to program the robot
Somebody's going to,
and you see, being isn't going to be behind that.
Right. And you look at there's all this evidence, really clear evidence of all the biases in these algorithms that were built in by the people, can't recognize certain kinds of people, literally can't recognize their faces.
Google is extremely biased. Yeah. There's been tons of research and placebo-controlled double-blind studies on it.
Yeah. So anyway, I think it's really interesting that, there's this, and this really matters for the search for intelligent life on other planets, because, we have to ask ourselves, what are we looking for? What kind of things will a civilization do that you could see using a super powerful telescope across 30 light years or 100 light years? And so that requires kind of trying to build some maps of how technological civilizations evolve.
Yeah.
Earth actually has some very unusual characteristics compared to other planets in our solar system and maybe other planets in the universe. Does that mean that it's rare, that life would be rare?
Two questions. Well, first one, what are the biggest differences that we have found with other Goldilocks planets and Earth?
Yeah, well, the thing is, we haven't been able to, we just now are getting the ability, and we're still, even the James Webb Space Telescope, as powerful as it is, are just beginning to get the ability to actually look at them in detail. Up until James Webb, the main thing was just finding them. There's a planet in the habitable zone, right? Because it's hard to find planets. You can't see planets directly.
It's mainly the color of it, the color, right, is a big thing.
Well, even that, we're just be able. So here's what you want to do if you want to. So first of all, finding a planet, you never or rarely can ever see planet directly. You have to look at the star and look at changes in the star to infer the existence of a planet. So for example, one thing, the main way we find planets is by what we call transits, which is like a little eclipse. The planet's going around the star, and if the orientation of its orbit is right, it goes in between us and the star. And what you'll see is a little teeny tiny dip in starlight. And so it took decades to build the instruments that could see like a 1 in 1,000 dip in the starlight, right? Now we've gotten really good at that. So we're very good at finding those dips in starlight and using those dips to infer how big is the planet? How massive is the planet? We actually need other things to get the mass. But one of the amazing things you can do with this is if the planet has an atmosphere, like a little veil of gas around it, when it's passing in front of the star, when the planet is passing between us and the star, some of the starlight will pass through the atmosphere and get to us, right? And when it does, the chemicals in the atmosphere will absorb some of the light. There's a rainbow going from the star through the planet's atmosphere, and some of that rainbow will be sucked up by chemicals in the atmosphere. It was called a spectra,
right?
And or absorption spectra. And every chemical, every element, every molecule has a very distinctive way it absorbs light. So it's like it's a fingerprint, a spectral, a light fingerprint. So we get that light, with our telescope, and if the telescope's big enough, it can collect enough light that we can then spread that light out and say like, oh, look, some of the light was taken out at this wavelength, and then twice that wavelength. That's carbon dioxide. So you can be like, holy crap, there's carbon dioxide in that atmosphere. So we're just, like we can do that for big planets, like Jupiter-sized planets. We're just at the hairy edge of being able to do that for Earth-like planets.
Got it.
So we don't really know yet what a Goldilocks planet. We're not there yet. But the point of my book, when I was writing it, was that what is so exciting is that in the next 10, 20, 30 years, we're building the next generation of telescopes. That's what they're for. They are going to be able to collect that light and look for things like oxygen. Like if you find oxygen in a planet's atmosphere, that may be a determinant that there's a biosphere there, right? Because all the oxygen, this is a crazy idea. If you were to land on Earth 3 billion years ago, there was already life. You would have found like bacteria, mats of bacteria. But if you stepped out of your spaceship and took your helmet off, the first thing that would have happened is you would have died because there was no oxygen in the atmosphere. There was nitrogen and there was some carbon dioxide and the other stuff, but there was no oxygen in the atmosphere, right? Anybody take a deep breath. Where's that oxygen come from? It came from life. Like somewhere about 2.5 billion years ago, microbial evolution, figured out a new trick, which was how to do a kind of photosynthesis that used water. But there was photosynthesis before that, but it had to use like iron ions in the ocean, and there's not a lot of iron ions in the ocean, so life was kind of limited. The food was limited, and then about 2.5 billion years ago, life figured out through evolution how to use water as the basis for photosynthesis. The chemical shenanigans that take a photon, a light ray, and clank, 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 turn it into a sugar molecule that you can eat. And that changed life forever for two reasons. One, suddenly there's water everywhere, right? So now suddenly there's all the food you could possibly, for photosynthesis, you could need. There's all this water that you can use to turn sunlight into sugar. So life just explodes. But the second thing was, like, what happens is life, the microbes, inside the microbes, they take the water molecule, H2O, they split it apart, they take the hydrogen, which is a proton, they use that to build the sugar, and the oxygen they fart out. They literally so all this oxygen is getting just pumped back out into the oceans first, and then into the atmosphere. And it takes about maybe half a billion years, the atmosphere fills up with oxygen. Right? They call it the Great Oxidation Event. And it took a little while. But that is why it was life that put oxygen into the atmosphere.
Wow.
Isn't that wild? So if you find, because if tomorrow all life on Earth went away, all that oxygen would just recombine with the rocks really quickly. Like if life disappeared tomorrow, you'd come back, and I'm not really sure what it'd be like, a million years, the atmosphere would have no oxygen in it. Right now it's got 21% oxygen. It would all go away. So that story is...
So if you're saying all the life disappeared on the Earth right now...
all the oxygen would go away in the atmosphere. Because the only reason there's oxygen in the atmosphere is life keeps farting it out. It's it is a product of biological photosynthesis. That is what every day is pushing oxygen into the atmosphere. So every day oxygen is pushed into the atmosphere by life, and every day oxygen gets bound back up into rocks. So if you remove the life, if for some reason magically you could make all the life go away, what would happen is the 21% oxygen that's in the atmosphere would just get...
What would happen to the plants in the rainforest?
Let's say magically, if I could take life away, right? Then the oxygen in the atmosphere would go away. So the reason I'm saying that is that, so what's important, what it tells you is that if you see oxygen in a planet's atmosphere, right? Like that whole thing I was just talking about, that tells you that there probably is life there. There's probably a biosphere there.
Right. That
So
makes sense.
You will not have oxygen in an atmosphere, in a planetary atmosphere, most likely without there being life to keep pumping it back in.
Right. Okay.
Right.
That makes sense.
Yeah. So the other thing, so that story has two important points. So it shows us how we're going to characterize, how we're going to look for life on distant planets, right? Because we're not going there anytime soon, right? So how can we see life? How can we see signatures of biology, i.e. biosignatures, on planets that are 100 light years away?
Right.
Well, once we have these more powerful telescopes, we're going to be able to do exactly what I was just telling you. We're going to be able to look for the light that's passed through the planet's atmosphere, analyze that light, and look for compounds that can only be produced by biology. Yeah. But there's a second really important consequence of this, right? So what happens is these little critters, right, that 2.5 billion years ago that innovated and invented this new form of photosynthesis, they literally changed the planet, right? Having oxygen in the atmosphere changed everything about the planet's history. Oxygen chemistry is just totally different. So it's a really nice, very important example of life changing the atmosphere, which changed the climate also, radically changed the climate of the Earth. And actually, it was kind of poisonous to the critters that were around then. Like it was kind of a devastation. The invention of, this photosynthesis was good for a while, but then it pumped so much oxygen in the atmosphere those species of critters ended up, they had to like burrow into the ground, like get away from the oxygen. Oxygen was actually poison for them.
Wow.
So it's a really nice example of a species becoming very successful and in the process changing the climate in ways that wasn't so useful, for them. Sound familiar? Right. That's all we're doing now. So I'm just bringing it back to climate change now. There's people who are like, it's a hoax. It's dude, like this is what life does. When successful species change planets, that is important for us to think about our future. It's important for us to think about other technological civilizations. They probably change their planets. And also that whole thing that like, oh, it's a hoax. It's it's also very human hating. If you take the position that, a ridiculous position that like climate science, which has been around for so long, is a hoax, then it's like, why do you hate human beings so much? We did this amazing thing. Like we changed the atmosphere of an entire planet, right? We put extra CO2 into the atmosphere because we built this amazing global civilization.
Yeah.
Like it's indicative of what a successful species we are.
Well, I think that's the idea that the idea of the climate changing being a hoax is nonsense. But the problem with that term climate change is it's attached to so much political baggage.
Yeah, right. Which, but people, there's climate change happening.
Here's the problem. Whether you think it's a hoax or you think it's being overblown or you think it's a real existential threat, the problem is the majority of people who are in both camps, they don't understand how it works at all.
I know. And that's as a scientist, that's what I'm trying to say. There's what I always want to say is there's a difference between the scientific problem of like, what are the radiative properties of the carbon dioxide molecule? Like that does not care about who you voted for, right? So the climate is changing because of our activity, because that's how climate works. Like you put more CO2, it's basic climate science. I literally teach this to my undergraduate non-science majors.
Yeah.
Simple theory, the simple formula I can show them for how put more CO2 into any planet's atmosphere, planet's going to warm up. So that part doesn't care who you voted for. So there's a difference between the scientific question about climate change and what drives it, and the political question of what you're going to do about it, right? So you have to separate those two. Not doing anything about it and say, that's a policy too.
Right.
So somehow as a species, and that's why somebody called this is humanity's final exam, right? You've triggered climate change, because of your success. Now, what are you going to do about it?